Yeah, so this talks about CI/CD. We're mostly going to be kind of poking at the whiteboard, we can all yell at each other and raise our hands, whatever. It's totally just going to be a little free form. I have notes on my website that are on my phone, so you may see me doing this a lot, but they're helping me remember what I'm talking about. I'm going to share that with all of you via Meetup and on Discord afterwards. Don't let me forget. But it will be available to you for that, so you can read and disagree or agree or whatever. So let's start with what is CI/CD. So what was interesting is I think I heard two different people say two different things for what CD meant. So what's CI stand for? Who knows?
Continuous integration.
Right. So let's talk about. So what we're going to do is we're going to sort of I don't even know if I want to call it like a building this pyramid of ideas. But we're going to talk about. Okay, we're going to start with CI. That's continuous integration. So we're going to write integration because and my handwriting on the whiteboard is terrible. So for the posterity of the video, you're going to find out how great that is. And so CD was one that kind of had two different definitions, right? So we'll start with the first one. I'm going to use delivery, and then continuous deployment, right? Exactly. And so again, these are sort of arbitrary words, but I'm going to define what they mean. Again, this is an opinionated introduction, so you can totally disagree with my opinions here, and that's okay. We'll talk about these ideas and why we want to do this, or why we might not want to do this, and why continuous deployment might not work in your scenario if you're, I don't know, like putting something on an aircraft or something that's physically separate and you can't put things there without physically being connected. So there's all kinds of. I don't want to kick over your bag. I'm just trying to get that little speech. Okay, so and then it fell. I'm sorry. So we're going to talk about each of these, and the way I'm going to sort of approach this is what we're going to do is we're going to talk about each. We're going to start here, and we're going to sort of kind of like level up as we go, because each one of these becomes harder and harder. And then we're going to talk about ways where once we've gotten to a certain level here, you can go even deeper into the matrix of this thing. So let's talk about what is continuous integration. So for most people nowadays, what we're going to find is a lot of the tooling for all of this makes a lot of this stuff very easy. So for example, continuous integration. So a lot of times when people mean continuous integration, they mean as people are making changes to a code base. In fact, I'm going to draw a little diagram. So let's say we've got our a lot of times this is called the trunk. So on this line, this is the version of the code that is the main version of the code. It's the one we can rely on. It's safe. We know it works. And throughout the day, throughout maybe the weeks, the sprints, whatever your sort of interval of time is, there's always people kind of making changes, and they're getting back in to this main kind of working. And if you know Git, branch would be what that's called. Typically, it's called main. I'm going to use Git because most people are using that these days. So most people are sort of making these changes, and they're sort of making their way into this main. Sometimes it's called a trunk. If you've done SVN before, that's called trunk a lot of times. So the thinking here with continuous integration is that we're trying to facilitate getting this change into that main branch. So there's lots of really great tooling out there to help us do that. So one is source control. A lot of the source control tools now make merging my change into main very easy, or your change into main very easy, right? Git we take it for granted. If you've ever used source control, it just does this pretty easily. And what's even better is there's now even better tools on top of that. So you think about something like GitHub, where instead of just merging this change over, we can have someone review it before it goes through. We can add checks in place. And so really when I say continuous integration, what I mean is we want to facilitate taking changes to our software and working them into the big sort of main global trusted place where we know the software works. Let me make sure I check my notes, make sure I'm not forgetting any cool important points. This may go really fast, and I may find that I only wrote like 10 minutes of stuff, but we're going to find out. Okay, so one thing worth thinking about is that sometimes the changes that you make could just go in there. For instance, again, I'm going to use a specific example. GitHub has a feature where they'll look at your dependencies. Let's say I'm going to use Python, for example, and I'm using Django, for example, a web framework. And a new version of Django comes out. It's like a small change to Django. It probably fixes a security flaw, maybe. It might just improve some performance thing. If it's a small enough, safe enough change, it could just automatically go in. I don't see why not, right? What's that?
Can that be done with unit tests?
So we're gonna get to that. So that's a good question. So that's a good lead up to where we're going here. So one of the problems with just merging stuff in is like, well, how do I know it's good, right? How do I know that it's okay to merge? How do I know that main is safe, right? Is okay for it to either go to a website or go to an aircraft or go to your phone or wherever. So a lot of times what we're going to do is we're going to build these checks in place. And so this whole talk's about CI/CD, but it's a little bit about just DevOps in general and this idea of making the software delivery process good. And unit tests can be a core part of that, right? So in the case of I bumped Django to, I don't know, what's the newest Django version?
5.0.
Okay, so 5.0 and then 5.1 comes out, okay? And I bumped that version, do I know if it works or not? I need some sort of checks in place to figure that out. I need to check that, you're managing this code base and I say, hey, I'm gonna add this new feature. Well, you wanna make sure the new feature is not busted. So you don't wanna just merge this willy-nilly, you really wanna have some checks in place. And so what's interesting that's happening here though, is we're talking about continuous integration, but what I'm totally suggesting right now is that we're adding friction at this part, right? We're saying, well, hey, I don't want to just go in there at any moment. I want to know that it doesn't suck, that it works. And so there's a push and pull, there's a tug, there's a balance here to be struck between something like have a million checks in place before this integration happens. And again, it can just be a git merge and there's no friction, but it could be busted. And so the balance is safety versus going fast. And this is going to be kind of the recurring theme for all of this is we're going to be balancing, we want things to be safe, but we also want to not wait forever, because when we wait forever, we actually increase our risk when we deploy. So, because large deploys kind of typically have more risk associated with them, more things change at once, that can be a problem. So that's what continuous integration is. What's nice is that most of us kind of get this for free if you're using source control. And I know that, like, for instance, in some places they can't use source control, and so there's someone who's managing this as their job. That happens sometimes. So sometimes integration is actually really tough. But for most of us these days, source control makes this really easy. There's lots of great tools on top of source control, Bitbucket, GitHub, that make integration really great. You can really build workflows around that integration process to make sure it's safe, to make sure it's good. And it's really up to you to kind of figure out what safe means. Does it compile? Well, it's probably a good idea. It's probably should compile before you merge it. Maybe does it pass some sort of stylistic check? Flake 8 if you're a Python person. ESLint for JavaScript. Go format for Go people. That sort of stuff. So integration pretty well understood. Let's talk about this. Kind of tease these two apart because I'm going to pick a definition. These are my definitions. You can disagree with the definitions, but I'm going to separate them because I think it's important, and I think they build on top of each other. So about delivery. Delivery is kind of the next easiest thing. So,
before you go, I got a question.
Sure.
So you consider continuous integration anywhere from I just have a main branch and I'm checking code in, to I have a team that's committed PRs with QA checks and then a product manager actually approving that PR and then getting built. Is that the range there?
Not even the build. We're getting to that build part. That's where the delivery part's coming in. So for me, integration is we've got a working branch where we have code that we think is the source of truth, and getting that in there easily, lowering that friction. That's where the integration is happening.
Okay, but what I'm saying is that the range you're saying is something as simple as I'm merging code in willy-nilly, or I have a linter, QA checks, and PR approval before that code is merged to main.
Correct.
Okay.
Yeah, exactly. So to me, it's all about protecting just the main branch on your code base.
Okay.
And figuring out what the right sort of balance is depends on what you're building. You know, if you're building banking software, you might have different checks than if you're building, say, a game or something, right? You just have to kind of figure out, again, a lot of this is like, these are ideas, and you have to look at your product and what you're building and your team, it's kind of the layout to figure out what kind of works best. We went to sleep. I don't know if that means we stopped recording or not. Let's hope not. Let's just keep going. All right, so software delivery. So this change, we've added a new feature. It's made it into main. We think it's a good idea. We think it works. So now what? Without any change, you now have some code that's checked into Git and it doesn't do anything. So when I say delivery, what I mean in this particular case is that we're going to take that code and turn it into, the buzzword here is artifact. We're going to take, like let's say it is your Python Django cool app or your Express.js cool app or your Go pure HTTP Go and it's blazing fast and it's memory efficient. You're going to turn that into something that you could deploy. So like maybe a Docker container, maybe it's, if you're an AWS person, maybe it's a custom EC2 image, like an AMI, AMI, depending on who you ask. Either of those, right? So we've gone past just code checked into source control that we trust. We've turned it into something we could do something with. If you're a Java person, maybe it's a jar file. Maybe if you're building apps, it's an APK file, like an Android package, or something like that. So we've gotten past just code to actually something that could be given to a user, even if maybe the raw kind of material is not exactly what they need, right? But like if you're an Android user, every one of those apps is basically just an APK file, which is basically a jar file, which is basically just a zip file. So it may be that you have now taken this Git source control and you've added some shell script or some sort of build process that takes the code and turns it into something worth having. So, so we've got maybe some, I'm gonna start drawing pictures. We're gonna build our big pipeline. So we've got, we got some files. They got all kinds of code and pictures and all kinds of cool stuff in them, whatever. People are making changes. The changes come in. It now turns into some sort of artifact. All right, how do we draw? What's the cool way people draw containers these days? I'm gonna use containers as the.
A folder sometimes?
A folder?
Maybe not.
No, sure. I'm gonna do like a box. Oh, maybe I can make it look like a shipping container. See, this is all just art practice for me. That was the whole purpose of this talk. It's like shipping container, right? Okay, so. I'm going to write the word container because we're not going to know what this is in a bit, and this is fast. So maybe an app, maybe it's a binary, maybe it's like a compiled exe, .exe or something, right? You ran make or something like that. The important thing here to point out is that this happened automatically. You and your sort of maybe dev workflow on your computer, you might be doing this all the time, just make sure it works, right? But whenever you merge it in, you say, hey everyone, this works. Automatically, that should be generated and put somewhere where people can get access to it. Now, who's the people that need access to it? That's the question you got to answer. For instance, if you built a container, you have like a project manager type person, they're not necessarily going to want to see a container, right? They're not going to run Docker on their machine, right? They're not going to do all that kind of stuff. They might look at the exe, that might work if you're building like a desktop application. So you have to figure out what that means. So we've delivered an artifact at this point. But this isn't necessarily always the most useful thing. We've solved something important though by doing this. For one, in order to do this automatically, it's got to be automatable. Right? That's a hard problem sometimes. I've got a bunch of files and the computer did some stuff and now I have an artifact and I can keep doing that as many times as I need. Every change I can keep doing that. That saves you effort. So back in the day, you might have to run that compilation yourself or you might have to go copy files into the right place. I can recall my first job. Right? So in our case, it was Visual Studio. I would hit the build button and I would get some stuff, some files, They could not be moved around, but they had to be copied all in one spot to this new folder, and then it would work. And so that's a script. You could write some code to do that for you. And so the problem that we've solved here is we have worked out all the wrinkles in this process, or you're going to have to work out the wrinkles in this process to make this build a single step. Whether it's run my script that does all the things, whatever it is, you have to solve this problem. This is sometimes very hard to solve. Sometimes it's really easy. Sometimes tooling is just there. For instance, most app developers, you can click the button in the IDE, but could you run it on the command line? Could you make the computer do it for you? Could you make another server do it? For instance, if you've ever done iOS development, Andres, yeah, do that on a build server. How hard is that? But that's a
much easier now.
Oh yes, that's a lot better. So for instance, iOS development for a long time was not mature enough to make this easy. This was a big pain, a big pain. I spent many hours weeping and blood, sweat, and tears over that. So that's delivery. That is sometimes really hard. Let's talk about deployment though. This is where it really gets bad, especially apps. Apps are really the worst in this whole space, I think. Deployment means not only did I get this artifact, I put it somewhere where users can get to it. This is the scary part, because now we take this container and we went and put it on our website. I got the little buttons up here or whatever, and then the logo, and there's some text and whatever, or it was on a phone the whole time, whatever. You have now gotten to this place where I took this artifact and then I went and put it somewhere where users actually can use it. Now for apps, this is a whole can of worms. But for the continuous deployment, that means I made some changes to our backend server, and then after some cogs kind of spun, it was live. It went to users right then and there. I made a change in my source control, and then 20 minutes later, 5 minutes later, hopefully very fast, it's now in front of users. That can be a really good thing, and that can be a really bad thing. I'll give you an example. Let's talk about CrowdStrike. This is the example that can going bad, right? They did continuous deployment, but they missed some stuff. So it's a great case study for this, right? So we've defined CI/CD. As you can see, there's two different CDs. They're both great. They're both important. I would say, in my experience, myself included, most people can get these done. Sometimes this one's really tough, but you can get these two done. But most people get a little kind of scared to do the second one, or they have limitations, right? Where it's not really big, it doesn't make sense for them. That's okay. If you can get there, that can be really good, but you got to have some checks in place. And so let's talk about that kind of stuff. So for instance, let's talk about CrowdStrike. What happens if you continuously deploy and then you deploy a whoopsie? What do? You've got to have a rollback. So one of the core things for continuous deployment is rollbacks. So there has got to be oh no, it's all gone terrible, it's all gone pear-shaped. I need a oopsie button. I need to press a button that can make it go back to where it was, and so I can say, okay, things are terrible, we need to recover, I need something. CrowdStrike didn't have that. In fact, the way their deployments were hooked up made it so they bricked their own rollback process. I'm sure they probably had something, but they didn't think about this as a potential test case where they could roll back from. So I'm sure they are solving this problem right now. So there's probably people still in the office still trying to solve it, if you know what I mean.
It also has the same problem as if you were an app developer, iOS or Android, you don't have rollback either. You can only go forward. A website is very easy to roll back because you control the servers, but you don't control people's devices, and that's also what CrowdStrike had a problem with.
Mm-hmm. Right. So, let me make sure I'm just not skipping over anything really important. Blah, 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 a bunch of stuff. So let's get this rollback a little bit more. So what I mean by rollbacks is some people sometimes they just need that to be a button. Like, oh, it's bad. This is the state I want to go back to. Please do this now, and it lets you know that it's done. Sometimes that means it's automatic. Can you do an automatic rollback? How would you do that? What does that mean? I'm just gonna add manual. All right, that kind of makes sense. You know, sometimes that might just be a script that you run to say, oh, go back to this state. Here's the new state. Go back. Please go back right now. Gosh, everything's going bad. The other version is an automatic rollback. And so, what does that mean for us? How do we, we've deployed this really bad thing. What do we do? So, this is where, again, this is why this is turning into a DevOps talk, is that you need monitoring, right? You need to know when things are bad, you need to know when things are good. You need to figure out, what does it mean for it to be good? What does it mean for it to be bad? That's actually the hardest part. Like, when is it bad? Is it, like for instance, I've got a website, it's an API. Well, requests are taking 20 milliseconds. Is that bad? Well, it depends on the website. It depends on what you're doing. Well, now they're taking 200. Well, that might be bad. Now they're taking 2,000 milliseconds. Well, that's probably pretty bad, And so there's a point, there's a cutoff there, and you have to figure out what that means for you. Or let's say it's something else. Maybe it's, you're doing machine learning stuff. Maybe it's RAM usage. Well, hold on a second. This model training shouldn't be taking this much RAM. This is a problem. Maybe something's up with the way I'm doing the training now. I need to roll this back and figure this out. And it's affecting people in production. So these sorts of things, you have to figure out what that looks like for you. Sometimes that's you're building, again, I'm going to use AWS terminology because that's what I'm most familiar with, is this idea of you're building, like in the case of AWS, it's CloudWatch, right, where you would be building, you would be monitoring, some metric on some service. For instance, in some of the services I've worked on, we had a queue of tasks that we need to get done. Whenever we would do a deploy, we would look at that queue, we would watch the queue, because if the queue started growing in length, that meant we were falling behind and something has gone wrong. And so then we say, okay, we got to back out, we roll back, and then the queue gets worked off. And so that's one potential way. But there's other things you might monitor. It might be requests, it might be your database CPU usage. There's all kinds of stuff you could watch. But again, I'm not trying to be very prescriptive on what you need to do, because your service might not be like my service or the next person next to you, the person next to you's service. And so part of it is you're all smart people, figure out what works best for the thing you're building and say, well, okay, you start with your own intuition, right? You say, well, why do I think it's bad right now? What is it about that's telling me that I think something's wrong? Can I make that automated? And this is again that DevOps mindset of like, well, instead of me being the person that always just kind of checks the website every time we deploy something, can I have something that checks the website for me, right? Do the same thing I was doing, just do it consistently, do it fast, do it every 5 minutes, every minute. And so I don't have to refresh the page every day of my life for the rest of my life, right? I can have a robot do it and then flag it. And by flag it, let's talk about that. Well, what happens when something goes bad and you roll back? Well, someone's got to know. So you've got to build out some sort of alerting.
That's not what people were using Selenium for?
Exactly. Selenium's a great example of that. In fact, that's what we do. So again, I'm not going to preach the AWS gospel, but there is a tool inside of CloudWatch that does basically Selenium.
Okay.
It'll go to a website and do some sort of interaction that you program, in this case like Python or JavaScript, and say, okay, did the interaction go through like I thought it would? If not, raise the alarm. And in the case of where I work now, raising the alarm means ping all the DevOps people in Slack in this one Slack channel. But it could be page somebody. That's what we did at Amazon. We got paged for everything. Any little blip, we got paged about everything. So maybe pager's not always the right answer, but figure out what alerting looks like for you. What's going to get people to respond, but not also be a lot of chatter where it's like it gets lost or it's so much that you stop paying attention to it. And also figure out what's the sort of way you want to measure that things are okay. Sometimes it is going through and clicking buttons on a website, like Selenium was a great example of that. Puppeteer, if you're a JavaScript person, is sort of the new hotness in that realm. Sometimes it is just curl. Honestly, I've written plenty of health checks that is just a shell script that runs curl against the thing, and it came back 200 okay HTTP status response. There's a bunch of different things. If you're using GraphQL, the way we do it at PBS is we have a barrage of GraphQL queries that we know to be gnarly and cause problems. So we go and run those every time. We make sure that that one failed. That's a problem. We need to roll back. And again, we're not even full CD there yet. So it's always an ongoing battle. So we're ongoing probably trying to work through and make it better. Let's see. So we're talking about learning. This talk is just, this is not how I laid it out in the talk, so this is going off the rails, but that's okay. What's up?
How often have you rolled back in your experience?
A lot. Sometimes unnecessarily so, because our metrics, our monitoring was a little off.
Okay.
Sometimes we've rolled back because of a glaring thing, and sometimes we roll back way too late, right? Where we went, oh, it was wrong all this time and we didn't know it. That's what really sucks. Then you get like the post-mortem, right? You get that shameful experience. But no, those are good. Those are good things to do. What's up?
I was gonna say what you might have been thinking, especially like with iOS development comment earlier. Like, I feel like for my career, like I've rolled back, like done a true rollback, like very few times, but have like done like a fast follow,
Fix.
many times. And so sometimes that fast follow is like kind of a rollback, but still like a git reversion.
Yeah.
But still like a brand new artifact and like pushing forward,
Right.
just because that's faster than learning the rollback method.
Right.
Because nobody remembers how it works. So.
Exactly. What you got?
How would you go, or do you know about A/B testing?
Mm-hmm.
How would that factor into this? I know for machine learning, you basically have two variants of your model and test it on different users to see the feedback from the users.
A/B testing wouldn't have anything to do with this.
Well, we can. They can interplay. We'll talk about it because I have a little spiel on that too. So that there is a little connection, or they could potentially be connected. So, but I think everybody made a really good point. So sometimes rollbacks. Some people sometimes building out logic for doing rollbacks is a really big pain and it's hard to maintain. And so sometimes it's easier to just say we only go forward. And if there's a problem, that's all hands on deck, we fix that problem. And so this is why continuous deployment is really scary, because people want to feel very confident before they put it out there and they can't roll it back. So again, you have to weigh your options. I would say, in my experience, all the infrastructure as code tools I work with didn't have really good rollbacks built in. I've used Terraform, CDK at this point, and a bunch of shell scripts, and those certainly don't have it. But Terraform doesn't, and I'm like, the only way for instance with Terraform, we use a specific example, which is an infrastructure as code tool. You just go to the old committer, you do a revert, you just git revert, and then run Terraform apply again. So you're just always sort of just going forward. You just roll forward. I don't know how to kind of like put it into words, but that's basically what you're doing. So, but let's talk about A/B testing. We'll get to it in a second. What I'm about to talk about is very related. So one of the risks with this continuous deployment idea is that, let's say you've made a gigantic change. The more things you change, the more risk you have of breaking things, right? And so it's helpful to release little things at a time, lots of little bitty things all the time, because when something does break, you know exactly what it was. You only did change three tiny little things. You know exactly what the problem is. But if, I'm gonna pick on you, David, you released, thousands of files of changes for some crazy reason, which that would be really hard for one person to do, but I'm going to pick on you. So you've changed all these files all of a sudden. What was the thing that caused the problem? We don't know. It's so much to sift through. And so it's better to do these very small changes. But that kind of conflicts with the idea of, well, I'm trying to build features here. Sometimes features take a while. So how do I handle that? How do I handle, David's working on a thing and it's going to take a while, right? There's going to be a lot of changes before it kind of finally integrates. All of that integrating is going to be kind of tough to make it continuous, right? Because there's a lot of changes. It's a big code review. It's going to take people time. It slows down the process, which in some ways would be unfair to you, David, right? You work really hard on this. Now you got to wait forever for people to look through all of it. And so one of the ways you can solve that, well, just try to integrate as we go. I got a few things. I've got some of the baseline stuff going. Let me go ahead and get that review, make sure I get some feedback there, make sure people think we all kind of agree we're taking the right architectural approach. Well, we're going to continuously deploy that. So we've now got this conflict where I'm about to deploy something that's half-baked. I don't necessarily want that to be half-baked going live. So now we're going to get into this other idea. I'm going to move this guy out of the way for a second. Oh, I can't see it, good. Feature flags. Feature flags. Okay. So this is where it really connects with A/B testing a little bit, I think. So feature flags, there's a really cool, what is his name? Of course, now I can't think of his name. Oh well. He's a famous. I think he was one of the people that were in the Agile Manifesto, one of those crew. One of the, like however 10 or so folks. But he talks about feature flags on his website. And it's this idea of putting a feature behind some sort of control so that it doesn't reach users unless there's maybe some condition in place. So the easiest way to do that is like an environment variable. So like for instance, I'm going to write this in Node.js lingo. I'll do Python for folks. How about that? I think more people know Python. So I say os.environ. I always get that wrong. Then we'll do it as a dictionary. Okay. What's our feature name going to be? Dark mode. How about that? Dark mode. If we had dark mode on, do all this stuff. And then, as part of your deployment for this feature before it goes live, you go ahead and you make this dark mode variable, make it false. Then, this code is live. It's in the code base. It's made it to prod, but no one sees it because it's hidden behind this feature flag. Now, this is sort of like a very low-tech way to do it. Again, this is a string. I know Python people, this is actually a string. It's not a Boolean, whatever. But you can wrap this in a library. You can make this nice. In fact, there's actually some really good open source standards out there for managing this. I have to dig that up as well. But so we've hidden it behind this environment variable. And what's nice about this is that, again, I'm sorry, David, I'm just keeping reminding you. You can just keep adding stuff here. You can keep adding stuff throughout the code base where it makes sense. As long as it's hidden behind this environment variable, it's hidden. And so the way this connects in my mind with A/B testing is A/B testing kind of works like this, where you've got this flag that's telling what the user's going to get. And, in the case of this particular feature, we did it with a feature flag that's environment-based, but you could do it through like a service. You can have an external service that manages your feature flags. And what's nice is that you can flip on a feature, wait a little bit, see if it does okay, flip it off if it's bad, and do it all through an external service. Otherwise, changing this environment variable, that's another deploy. So there's lots of different ways to approach it. Feature flags could easily, A/B testing can work exactly like this, or it can be replaced with an API call. It's a very similar approach. So they are kind of close buddies, and they can be implemented very similarly. And sometimes it may be helpful for them to kind of live together in the same system. You could see, like, honestly, the B of the A and B is just a different feature, right? So you could see that as enabling a feature flag. Now, environment's really a great way to do this, and the reason it's so great is because it's just another deployment. If you're managing environment, you're managing your infrastructure with something like Terraform, CDK, CloudFormation, whatever, those are set, those are just values in the code. It would be reviewed code. It would go through all of your integration testing, all of your sort of workflow would be there to just turn on the feature. And so, David, when he's working locally, can turn on the feature, do all his work and kind of see how it goes, and yeah, this is great, and then say, well, I only want my product people to see this in our maybe staging environment. We'll get to that in a second, but like in our maybe like a pre-prod environment where it doesn't go to everybody, but it does go to internal people. Well, then I can set this environment specifically for a certain place. And so there's all kinds of ways that you can manage this where it's still always going live and you're not blocking anyone else from deploying, right? David's doing his thing, but Matt, you're deploying other stuff. You're fixing this critical bug. This new feature is still ready to go live at any moment, or it's getting ready to go live, and you're not blocking your thing. So, feature flags are really helpful for that. It does tie into A/B testing, in my opinion, in that way. Again, this could be an external service. This could be done lots of different ways. The environment is the easiest and fastest way. It has its goods and bads. Worst case, something's really busted, you go in the console yourself and go hit a button, so there's always a and encore if you want to use that phrase. So, cool. So,
I think it's worth, if you
go ahead, yeah.
So with feature flags, it's worth adding that yes, you can have an environment base, but one other useful way to think about it is segmenting by people, and this is where some of these like vendors come in, is to your point about A/B testing, like how do you get it to different populations? So with a lot of feature flag libraries, you can segment your groups and say, hey, you're in bucket A and you're in bucket B, and this is how we test out, like, is that feature working? So
Right.
it's more than just the, is it live or not, as kind of a binary. It makes it more of a spectrum on whoever your users of your service.
That's a really good point, is that you can replace the innards of this if statement to be something far more complex, external API call, and then the world's your oyster. You can do all kinds of stuff. And it could be an internal system that you build, or it could be a system that you pay for, right? It just kind of depends. And again, this could still be an app, right? It's easy to kind of frame this as, oh, this is a website or something like that, but no, this could actually still be a binary, right? Especially if some of these things like this are remote controlled, right? You could turn off the feature and the app's live in the store, and this feature was busted all along, whoops, you didn't realize it, we'll just turn it off and never had to do another deploy, go through all the app approval process, go through, gosh, you have a Microsoft desktop app or something, have to go through all that, right? So,
Oh yeah, it definitely helps with iPhone or iOS and Android apps because the deployment process takes forever for that.
right. And so a lot of savvy app developers, I'm sure Andres, you can speak to this, is that a lot of savvy app developers are using stuff like this, or like, if you think about something like, Discord's a great example. It's a desktop app, but it updates kind of in place as the whole Electron stuff. That's them working around how hard it is to deploy an app. So they're using continuous delivery and deployment all the time, but they're doing it in a way to kind of circumvent some of the app store processes, the sort of internal operating system sort of checks and balances. So they're being a little clever. And maybe that's good, maybe that's a bad thing, that's for you to decide. But, it just shows that, like, with a little bit of, cleverness, you can maybe get away with some things. So let's talk about this deployment stuff again, because I've made some changes to main, and then they just go live to prod. That's pretty scary. So there's this other idea worth considering. It's this idea of modeling your deployment as a pipeline. And what I mean, and so I kind of even drew the pipeline, but this is a pretty bad pipeline because we've got some files, they change, and then we get an artifact, and then just go straight to prod. And so really what ends up happening, what can happen is that you don't have a lot of chances to catch flaws before they just go live to everyone. So that can be bad, speaking from experience. And so a lot of times, what a lot of teams like to do, they like to sort of, instead, again, going back to this kind of idea of these changes flowing to prod, they add other sort of stages in here. So here's what we're going to do. I'm going to add some more stages. You can pretend that app is always there. We've got this artifact, and then it maybe goes to like a dev environment, maybe staging, and then maybe it goes off to prod, and then all the users are so happy to see it. And what's nice about this approach, I'm going to talk about some of the, we're going to the internals of this. I want to watch my time, make sure I don't jabber for hours on end. We're getting kind of close to the end, I promise. So the changes go, and they hit a development environment. This sort of, these environments, these are sometimes called stages, is what I've heard this called, which is confusing because people call this staging. But these sort of stages, and what I mean by stages is they're basically all duplicates of the same thing, but the visibility is different. So for instance, in this development environment, a lot of times, in my experience, that's meant only people that are writing the code, or maybe some product folks, can see that. And so what that means is that if it's really busted, no one else saw it, it doesn't matter. It's for me to go there and try stuff out. Oops, it broke, sorry. In fact, in my work, we call that playground. Just to kind of like hammer that point home. That's our playground. That's where we go and mess stuff up and giggle about it later, right? But once it gets to staging, that means we think this is ready to go live. That means that we might run some QA here, We might do other stuff. We might, run maybe a harder sort of test. We might hold it to a higher standard. There might be all kinds of stuff that goes in place. In the case of apps, this may be where the person starts adding metadata. We can talk more about apps in a second, but again, I'm focusing on websites. I don't want to focus too hard on just websites. But if staging is good, it'll go to prod and users get to see it. Now, how does things make it from stage to stage might be the question you might be asking. So like it's in dev, how do I know when it goes to staging? So in the past, what people do is they would go look at it and they'll go, yeah, it looks good, and they hit the button and off it goes to staging. In fact, at where I work now, for our website, for pbskids.org, this is still a manual process to go from staging to prod, and there's reasons for that. We have certain reasons why we do that, and they make sense. And that's okay. Like for instance, we have physical, like human beings that are QAing the website. They're humans. You can't automate that. And so sometimes this is a manual process, and you're really violating that continuous deployment. And you have to weigh it out, right? You have to figure out what works for you. So the question worth kind of posing to yourself is like, for my thing that I'm building, what is the standard by which the code, the thing I'm building, has to meet in order to go from dev to staging, and then from staging to prod? And how can I automate that? So for instance, to get from dev to staging, there might be just sort of some very basic tests, like does the site load? Does the search bar still work? If I do a search in the UI, does it, do they actually get some values back? And do I get like the obvious answer back? Stuff like that. Staging might be like, okay, now we're going to go through lots of different user interactions. We might go through, running database queries to make sure things are working. There's a whole barrage of tests you can do here. You can get into like how to write tests is like a whole other talk, right? That's like a whole different talk that I could probably spend another 3 hours jabbering about. So we're not going to do that, but it's worth figuring out what types of tests that for you, again, for your product, makes sense to say this is good enough to go from staging to prod. In the case of where I work, one of those tests is a human being looks at it. That's fine. We have there's compliance things for some people, and that's okay. But in a lot of cases, no, there's nothing stopping you from automating all of that. So there's a couple APIs that some of my teammates own, and I'm like, you're going to be CD when I'm done with you. So, and I need continuous deployment. It's already delivered. That's done. We need deployment. So what's interesting is this is where most people get to, and I'm going to give you kind of I don't want to overrun my time because I have other random crap I could totally talk about. It's 8:07. You want to go? Can I give you 10 more minutes of weird stuff? Okay, so I'm going to give you some cool, crazy big tech things that I've seen done with this sort of deployment pipeline. It gets really wild. Okay, so we need more space. Goodbye, Git branches. Okay, you make for a pipeline. So let's say, all right, so we've got our source code, SRC, we've got artifacts, right? We've done our due diligence, we've got continuous delivery. Now what? All right, I've seen this, I've seen people have an alpha, a beta, and a gamma, and then a prod. And at each of those stages, they're running different types of tests. This is like the dev environment. You just poke around whatever you want. Okay, integrations tests have to pass. Some end-to-end tests have to pass. Load tests have to pass, something like that. Or they might do some mix, like there might be, some load tests here, but the really difficult ones happen here. That might be something you do. Or, oh gosh, let's get even crazier, okay? So gamma needs to be just like prod, right? Because we want to match prod because we want, when I run those load tests, to mimic what would happen in prod. And so, okay, well, my website isn't just in the Dulles region right there, which in AWS lingo is US East 1. No. We're going to deploy to US East 1. Oh, this is Gamma though. Oops, I'm messing up my letters here. US East 1, that's Gamma. Okay, great. Well then after that, then we'll roll out to 2 regions. US West 2. And maybe Dublin. What's that one? That's EU West 2, I think. That's Gamma 2. So you might roll out to more and more regions, right? You've got this global service. You're building S3, you're building Dropbox, you're building something that's really high scale. So you're going to add more and more regions. You're going to be running tests on each one of these. And you can see now why you've got to automate it. Because if you had 40 stages you've got to get through, you've got to know it's going to be working at every single stage. You've got to have bulletproof tests to make sure. And you've got to be testing everything from, integration tests, can my database query still work? That's great. Okay, stylistic's great. Load tests, smoke tests. You've got to be testing for crazy randomized things that only happen sometimes. Like the joke like cosmic rays. People say, oh, the cosmic rays broke my code. It wasn't me, it was those cosmic rays. S3 has that problem. Sometimes, literally, a cosmic ray zaps a disk and it flips a bit. They've got to have tests for that kind of stuff. And so you can see how, this is just Gamma, we haven't even gotten to prod, right? You might roll out to less stuff in Gamma. And you may even split, so like, okay, again, AWS specific lingo, this US East 1 may have multiple availability zones. So you might want to spread out your deployment over multiple availability zones. Remember, you're serving billions of customers, and so you might have to really be very careful with your rollouts. In fact, the internal recommendation that they gave us a lot of times was really focused on take your time. Make it automated, but take your time. If you're going to roll out to 1 million customers, do it a little bit at a time. So that way, if it does fail and you didn't notice, you'll notice after a day. Someone's going to reach out, right? So this is that kind of stuff. And so the rabbit hole goes very deep. Most people don't need this. In my current role, I don't think I need this. With my clients that I've worked with in the past, I haven't needed it. You may get to a place where you need it. That's really cool stuff. This can go on, and then you roll out. It takes a week to roll out, but it's all continuous. It just takes a long time. Go ahead.
This is maybe a little step back, but thinking about with like the apps, a lot of apps will have like a developer build that, like, if you as a customer are interested or whatever, you can go and download like Firefox Nightly.
Yeah.
As one of those, or like whatever it is, and then I was also thinking with iOS specifically, they have like test flight.
Test flight, yeah.
So you can like be on that like beta list if you want. But yeah, just thinking about that.
Yeah, so going back to this pipeline thing for apps, let's talk about apps is weird because if you've never done an app before, right, so you may build your artifact and then let's put this into, you can upload into test flight automatic, right? And so now it's in test flight, it's in Apple's system, which for those who haven't seen this before, so whenever you build an iOS app, test flight is like the staging ground for testing apps for iOS. It doesn't go live to the store, because the next step is you've got to, and I may get out of order, so Andres is probably going to correct me here, and that's okay. You've got to add metadata, right? And by metadata, that's a human, like your product person, maybe you if you're building the app, typing all the things, all the screenshots, all the images, all the stuff, staging that release, and then you send it to review for it to be, potentially rejected for some strange reason that you don't understand. And then maybe it might just go live. And so there's a lot, sometimes when you think about in terms of a pipeline, sometimes there are human steps here, and that's okay. Sometimes it's unavoidable, right? I think it's great that I can't just push an app and then it just goes live. That's probably a good idea because metadata is what helps make the app experience nice for users, right? So if I can just push it live without any intervention, well, I'm potentially not helping my users. I'm actually making the user experience worse, right? So Sometimes these check and balances are helpful.
I will add that that whole pipeline there is all production. That, in no part of that would have staging there, because for you to actually test in a staging environment, it would have to be a local build, and then you have to have provisioning profiles for iOS,
Yes.
which is annoying. And then
Signing, all the signing
all that
stuff. Oh my
yeah,
gosh,
that's
yeah.
correct. You're doing an internal deployment to do that. So when you're in test flight, you are a beta tester testing on production.
Right. And this is where feature flags, A/B testing, some of that kind of mindset is really helpful, because you can add the sort of developer mode into your app. Most app developers do something like this, where if you go and tap in this certain place and go to this menu, you can switch to the beta version of the API, so you can see new features. You know, if for instance, a lot of people use GraphQL for the backend for an app or something, or that's the whole idea, whatever. But that being said, so there's all these sorts of ways people work around how tricky that is. And for instance, provisioning profiles are like this weird thing specific to iOS that you have to have different type of, yeah. So anyways, let me make sure if there's any other weird, dumb thing that I wanted to kind of cover. I think this is all really cool stuff. And I didn't even cover everything I think I had in my talk. I'm going to post all this. You can read all these notes. I think my delivery was probably far less organized than what's in here. But that's okay. Two different ways of having it. Yeah, and also in my talk notes, you also see I linked to some of the tools that are out there for helping you kind of build these things. You know, things like GitHub Actions, things like Circle CI. There's all kinds of great testing tools, like Selenium is a great one, great example. Puppeteer, all those sorts of tools. They're just tools. You have to figure out what works for you, and it may be that this is just not for you. You can't, because of the situation you're in. That's okay. If you can get that, that's great. Though. It can be very freeing. It can be very freeing. So well, thank you for coming to my TED Talk. Thanks, y'all. That's all I got.
Thanks, Jim.
Yeah. Any random questions? Everyone was asking questions. It's great.
I have a big one and a small one.
Big one.
So the big one is the answer to how, but I'm just going to ask, is it a solved problem? When you do a rollback, you're essentially adding a cycle to an acyclic graph, right? Is that a solved problem? Of like how to deal with that?
No. Rollbacks are really hard.
Okay.
And this is why, like for instance, Dave was saying, you just always roll forward.
Mm-hmm.
And because git revert is well understood, and we know it works. If you know what's wrong, you can revert the one thing and deploy that. And so that's been the easiest way forward that I've seen.
Yeah, it's typically like in that git revert, you're building a new artifact that is representative of the artifact from 2 artifacts ago. Like, it might be the same byte for byte, but it's just easier to like apply that as the thing you're gonna roll.
And you
That's why I
eliminate the
asked
cycle.
how often he rolled back, because I never roll back. It's always rolling forward.
Yeah. And so I'll say that internally, Amazon, the tools were there. But again, that was solved internally for a certain company. And I'm not even saying that that's the best solution for the problem. It worked for them for certain scenarios, but like for a lot of the stuff that I do now, I don't know if that's the right solution. Sometimes it's just, you just keep going forward. You only go forward, and sometimes that means git revert. But git revert is a revert, but it's still a new commit. It is a new artifact. So,
So the other rollback that you might see is like, you talked about manual and automatic. And I think where you might actually see real rollbacks to previous artifacts is when you have those automatic features that like, okay, something's failing, but I'm the computer and I don't know what to go to next. There's no roll forward. Mm-hmm. So let me just take the one that's right behind me. And like, I can do that in an automated way.
Yeah.
But you're gonna run into problems with like, especially with data changes.
yeah.
Schema
changes,
are where like rollbacks get really dangerous.
Yeah.
Which is what probably caused the fact that you need a rollback, because if it was
Well,
a simple
exactly.
you go back to like a previous artifact, is like then that would be the problem.
Right.
Yeah.
Mhm.
Yeah.
Yeah, you fix the bug and you introduce a new bug, and now you
Yeah.
roll back to the bug again.
Exactly. And then on top of that, this is the one that you really need to launch. It's like, okay, I'm building a feature, but I need a test for that feature, but it's behind a feature flag. And how do I test the feature? Do I have to have a breaking test, and then the feature comes along that fixes I don't have the answers there. You just kind of figure it out. You little bit, I don't know.
I just feel like feature flags are generally the right tool to solve this. Like, 'cause what feature flags do is they decouple deployment from release. So like you keep those concepts, like the release of the feature is like the enablement of it to actual traffic on users. And that's a huge thing where it takes your infrastructure out of the equation.
Right.
And avoids a lot of the rollback messiness. You can still have problems if the feature
Decoupling
flag
is
misses
right.
out data.
Yeah, decoupling is a really good word for that. I think it's the right way to think about it.
I'm just gonna say, I back to the rollback conversation. I have worked at one place where every time you made a database migration, you had to write and test your database rollback. It wasn't like super automated or anything, but it was like understood, like you checked the box that like I wrote the rollback and I tried it using like the staging data to make sure that it was possible.
Yeah, it drops the table.
Well, But that does make you think about things like, okay, if I am like, removing a column or something, I can't roll that back. And so you end up kind of rightfully not doing those kind of things in one go. You like add the new column, wait 3 weeks, and then roll back,
Yeah.
So it's like,
Yeah, we didn't even talk about like zero downtime deployments.
As soon as say the rabbit hole goes very deep. I think someone understands.
So what you guys want is a platform. I think we have solutions to a lot of these problems, honestly.
It's a hard enough problem that you really could just say, hey, I'm going to pay someone to solve that problem because it is a lot of effort. It's like all of those tests, someone's got to write that. That's a lot. That's code you have to maintain.
Yep.
And all the infrastructure to manage these deployments, to keep track of which features are live, that's hard. So, for certain.
I was gonna say, like, my current client has 3 like different types of CI/CD, processes, right? One of which is what you're talking about up there. The dev build would be their local machine, staging would be deploying,
Sure.
and then you manually push out to production. Another one would be a simple PR. Once that's completed, that's going out all over staging and production.
Yeah.
There. And then you have the iOS and Android development.
And again, it's all about risk management. There's a risk management aspect. Oh, I think you had a question.
This is more, I don't think there's like a right or wrong answer. It's maybe help satisfy my curiosity. Because I've only ever worked with like small dev teams and like currently support a couple of those, but everybody wears all the hats.
Yeah.
So I'm curious about like the AWS or the enterprise or PBS or what have you.
Sure.
Bigger environments, like who drives, like is there like a delineation, like this role is the one who's driving what this pipeline looks like, or who's making the decisions on?
That's a good question. That's a good question. I think it depends on where you work. Like for instance, I'll say that Amazon is famously, it's all over the web, they talk about this, where if you're a developer there, you're also DevOps there.
Oh.
And so you just wear both hats. And so everybody, which means that even as a software developer, you would have an on-call shift, right? Because you own the infrastructure. So like for instance, when I started there, I was like pure software development and I really didn't have the infrastructure background. And then I got a really good quick dose of it because I was having to learn DevOps really fast because I was having to build and design that stuff. And so that's like a scenario where like they are famously that way, whereas Google is very not that way. You're an engineer versus they have SRE people, right? So it's very separate. That's my understanding. And at PBS, it's sort of a spectrum. Like, so for instance, there's many people that I work with that are very front-end focused, and I'm like, well, I don't really know all this like Terraform stuff. I don't want to deal with that. But then, whereas many of my coworkers like, well, I'm a back-end engineer. Yeah, I'll write Terraform. Hey, your Terraform sucks, shit, whatever. Like they know enough to sort of say, hey, you're doing this, you can do this better, or whatever. And it's sort of a collective decision. And if you have a lot of different services, they all have different needs, and so it is kind of you're working together. Everybody's wearing a different hat, right? And so a lot of times it's whoever cares about it the most, who's the maddest at it right now,
so
right? It's like it's the same everywhere, right? It's like I'm the maddest at this right now. I'm going to go fix this because I'm tired of fooling with it. That's sometimes how it goes.
I can describe another pattern. So I work at a healthcare company, and we are kind of like the Amazon model where we expect developers to have operational responsibilities. They're on call. but the actual like pipelines that Chip was kind of outlining are done by, we have a platform team, and it's their job to like make app development easy to do. So they give all of the tools for doing the monitoring, like all these layers that like everybody needs to get this right kind of universally.
Right.
But then each of the like app teams have their own responsibilities. So there's like a split between who's building what part of the stack.
Right, and I think that's how PBS is trying to get to as well, where like, for instance, me as a DevOps person, I'm not on the dev team, I'm on a separate team, and I'm building all these reusable modules for infrastructure, like, hey, you need an S3 bucket, here's one that's perfect. It's perfect in every way, it's encrypted at rest, whatever, all your, it has logging enabled, all the things you like about S3 buckets, now just consume my module, you'll have a great bucket too. And I've sort of been a force multiplier, so that's kind of what, I'm sort of like the platforms team, but I'm just like one per. Well, there's other ops people, but like I'm the only kids focused ops person. But so yes, I think I interrupted you. Go ahead.
No, that's more or less what I was wondering what you were saying. The platform team, like in that situation, are they writing tests for or driving that part of it, or is that strictly?
They do some, yeah. So they like we have. So because we're a healthcare company, we have to comply with HIPAA and stuff like that. So which means like we have to comply with certain data retention laws and access controls. So we actually have two platform teams. One is our cloud platform team. They're the ones thinking of like at the database S3 bucket layer, like the really low level stuff. And then we have a developer platform team that is kind of building on a lot of the primitives that the cloud platform team is doing. They're thinking about Tecton deployment pipelines and Kubernetes.
Right, how to deploy a Python thing.
Yeah, how to build the Docker image and all that sort of stuff. So the two teams kind of work in tandem with each other, have just different sense of responsibilities in order to make sure we're compliant with what the government requires. Yeah. Good times.
Fun stuff. Yeah.
And that's been that sort of theme of like, instead of having an operations team and a development team, it's sort of kind of inverted in a way where it's like there are people that are thinking about it in terms of like, I'm building the platform to make the developers, like, for instance, I see my role as my customers are those developers, those other developers on the team, right? I'm building the tooling that help them build stuff that just works. And if it's got a problem, they know about it. So like the monitoring, all that stuff comes for them, they get it for free. They don't have to keep writing that. So I'm building these primitives, I'm building the cloud Lego bricks, right? And so it may be that on your team, there's a person that sort of kind of owns that for a little bit, or you kind of rotate out. Right? I mean, that's what we did when I was at PBS the first time around. So, yeah.
Other questions for Chip?
Well, for anyone.
Cool.
Thanks. This is great.
That's great.
Whew.